Good evening to all. Ethical Engineering YouTube channel is conducting this Ansys basic level training program. I'm delighted to see the participants from various age groups have been joined and shown interest to join for this Ansys training program. Not only from various districts from Tamil Nadu, the people from Kerala and people from Bangalore and people from other states of Karnataka also shown interest and joined here. So here I can see the people who are pursuing UG engineering degree also here. Some people are doing PG and some people are pursuing PhD scholars also joined here. I welcome each and every one of you. Uh, as you all know, this training program is scheduled for 3 days for a week. That is from Sunday, Monday, and Wednesday. For each day, we'll be having a session from 8 to 10 o'clock. Each session will be split into two parts. The first session will be a lecture or a demo session. It is from 8 to 8:50 around, or it will be extended up to 1 hour. After that, we'll be having a 10 to 15 minutes break time, and after that, we'll be starting the second session, that is Q&A and a discussion session. There, if you have any queries related to the lecture I taken in the previous sessions, we can you can ask your queries there in the second session, or if you want to have any discussion over that previous session also, we can have the discussion in the second sessions. That's what we split it into two parts. That is, the first half will be a demo session or training session, and the second half will be a Q&A sessions, so that it will be benefited from both of you. And in this throughout this training program, what you will be learning here, it is like since it's a basic level training program, we will be covering all the basics related to the tool knowledges, starting from geometry creation, uh, that is basics analysis systems we'll be covering, and we will cover all the basics tools, that is a space climb, how to design those things, and designing in a designer model, and how to set up the analysis and how to apply the boundary conditions. All those things will be, you will be covering those things. Okay, not by saying that if you take any problems means like you have to click these things and that things. This is not that kind of classes. Here we'll be teaching you that if you take in one problem means how you approach that problems, like why you are giving this boundary conditions, and the main thing we will be teaching here, it is how you approach the problem, and how you apply the boundary conditions. So is this the only way applying the boundary conditions, or do we have another boundary condition setups, like those things and all will be discussed. That's what we will keep it as discussion sessions. So there you can ask us like so in demo session I applied certain boundary conditions. So you can ask that why you should not apply in another way. Like I solved in one dimensional problem means why you can't able to solve in three dimensions. Each analysis have advantage and disadvantages. We'll be discussing all those things, and why I'm choosing this type of analysis, why I'm choosing certain boundary conditions. All those things will be discussed, and I will be explaining all the each and every steps. And if you have any queries also, or if you want to discuss, like if you give some alternative also, we discuss that also, and ultimately we solve both things, and we will get into a point like which is better and why that is better. That kind of sessions will be doing throughout the session. Okay, so now I'm share my entire screen. Okay, you can see that. uh, is my screen is visible to all? So uh, I already shared the link for how to solve software installation. Once you install the software, you can see that workbench. You can Once you open the workbench, you will see this type of window. So if you see that in the left hand side, uh, you can see that a lot of analysis system will be there. Okay, so each and every analysis system have to perform a different type of analysis. You have to carry out. Okay. The Ansys is it's called as a multiphysics. You can solve all related physical related problems here. You can see that left hand side in the analysis systems, you can see that the fluid flow, right? So you can solve that fluid related problems. That is the aerodynamical problem you can able to solve here. You can solve that thermal analysis also you can able to solve. You can see the thermal electrical also is that thermal electrical means you can solve the electrical kind of problem also here you can able to solve. So that's why we called as the Ansys software is called as a multi-physical platform. Here you can able to solve all related physical problems, physics related problem you can able to solve here. That's what we call as multi-physics. And here in Ansys training program, we are only focusing on structure related problem. You can see in structure related problem, a lot of problems there. That is model analysis, static structural, random response, response spectrum analysis, rigid dynamic analysis. This on all comes under the structural analysis. If you're talking about structural part means we have a linear static, dynamic analysis also will be there. For this basic level training program, we will be focusing on static structure. That is a basic level. In that model, vibration, uh, the rigid body dynamics and all, it's higher level things. As of now, we'll be focusing on static structural. And throughout the section, we'll be uh, solving one-dimensional problem, two-dimensional problems, three-dimensional problems using static structural, and we'll be validating the each and every problem with the analytical method. Okay, so the main here, the software, right? So whatever we are performing that analysis, we called as this is called as a numerical methods. Okay, if you solve any engineering problem, you can solve by three methods. That is, one is analytical method, and second one is experimental method, and third one is a numerical method. Okay, in engineering, we already studied. If you have any problem like if you solve any structure related problems, like let's take one cantilever beam. If you want to solve this cantilever beam, we know that how to solve by analytical way and experimental way. In structural thing, the main thing we are solving here, it is the two things. That is, first one is strength related things, and second one is stiffness related things. For example, if you have one structure and the load is applied on the structure, like for this cantilever beam, I'm taking that. For this, the load is applied like here. You can take this cantilever beam or real-time application if you take aircraft wing, because the aircraft wing is just like a cantilever beam, right? So for that structure, it is having subject to some load. Okay, so if the load is acting means that wind load and all we can't able to control. Okay, sometimes it will be maximum load is acting means that kind of load will be acting. Okay, so we can't have a control over that applied load. Okay, so whatever the load is applied, right, uh, that load has to be withstood by the structure itself. So that's what we are performing the strength analysis, like for the applied load, whether the structure can able to withstand that load or not. That is what we are first defining in the structural analysis. Okay, that is strength parameter. Second one is the stiffness parameter. The stiffness parameter is nothing but, so now I applied the load, the structure is withstanding that load, but it having too much of deformations, like the, if this is a small deformations, instead of that, the whenever as soon as I apply the load, it is deformed in this very large deformations means. So there comes the stiffness parameter. You have to control over the deformation also. Why? Because if you have too much of deformation, and it can, even if it can able to withstand that load also, what will happen, this will affect the other parts, or it will affect your own itself. Like if you are considering the wing structure, it will hit to the ground. or it will affect the some other parts of these other structures. Okay, so you have to maintain two things. One, the structure should withstand that whole load, as well as it should have the stiffness also. It should be having less deformations, so it should have high stiffness. Okay, so we have to consider two things. Generally we are considering two things in any structure related problems. Okay, so I'm taking this cantilever problem. Okay, so for this cantilever problem, if you analyzing any structure related problems, all are in real life it is a three-dimensional one. Okay, even if it is cantilever beam or we are considering the wing structure, right, that is a three-dimensional one only, right? So it is not one dimensional, all those things. Okay, so but whenever we are trying to solve the problem numerically, for certain times we have to assume that the structure is one dimensional, the structure is two dimensional, the structure is three dimensional, and then we furtherly we proceed for analysis things. Okay, so first we have to have a clear idea about for what problem, for what type of structures we have to think or assume it is one dimensional, two dimensional or three dimensional. We should have a clear idea about that. Okay, for example here we have taken that cantilever beam structure, right? So if you see that, so you take this lengthwise is you take this as x-axis. Okay, so for this you take this as y-axis. Okay, for this axis you take this as z-axis. Okay, see, in x-axis we have that length of the cantilever beam. So let's take this length L. Okay, so you have law length is maximum, x-axis is contributing more. Okay, for this cantilever beam I'm taking the cross section is square one. Okay, so if you take this, this is z-axis, this is y-axis of the cross section. Okay, so uh, this is y-axis and this is z-axis. So this is that and this is y-axis. This is a cross sectional of this cantilever beam. Okay, for this structure, from this you can see the x-axis have more length and y and z is comparatively equal. Okay, so compare with the x-axis, the z-axis and y-axis is very low, right? X is too large compared with the y and z. For this type of conditions, we have to assume that structure is the one-dimensional problem. Okay, if you take a paper or a sheet metal, right? So if you have the sheet metal or paper means, so you can see the x-axis. So for this we take this is the x-axis of the sheet metal, or this is y-axis. Okay, in z-axis you have the thickness, right? For sheet metal or paper and all, the thickness is very negligible. For this structure, if you see, x and y are comparatively equal, and compare with the third dimension, right, that is the z-axis, uh, x and y are somewhat larger. For this type of problem, like if you are analyzing surface related structure, that is sheet metal or a plate, if you are solving that type of problem, you have to assume that structure is a two-dimensional problem. Okay, so if you are considering the structure like a cube related structure, okay, if you see that cube related structure, you can see all sides are, that is in all the directions are comparatively equal. You can't able to ignore the other directions. So x, y and z directions are comparatively equal. So here only we have to call x and y z are comparatively equal. So this type of problem you have to solve by three-dimensional. So this is three-dimensional problem. So this is two-dimensional problem, and we can solve this type of cantilever beam as a one-dimensional problems. Okay, so we have to, first thing is, first we have to understand the problem statement and we have to see the structure, and then based on the structure we have to assume whether I can go with the one dimensional or two dimensional or three dimensional. Okay, and one more thing, if you ask me that cantilever beam whether you can able to solve by one dimensional alone or two dimensional alone or three dimensional, you can solve the same cantilever beam in 1D, 2D or 3D also. Okay, but most of the people will prefer one dimensional because it gives higher accuracy level will be more compared with the two-dimensional and three-dimensional. In throughout that analysis process, we'll be explaining each and every term, why that one-dimensional is giving more accuracy compared with 2D, 3D. All those things I will be explaining in later sessions. So since this is the introduction part, I just giving that hint of these things. Okay, so suppose I'm solving that basic level problem. I'm taking that is I'm taking the cantilever beam problem means. So what I have to do, like if you see this workbench itself, as soon as I click on the static structural, okay, because as I said, we are covering the basic level problem. Here mostly uh, we'll be solving related to static structural analysis. In that name itself, you see that we are solving the structural problem at static condition. That means if you double click on this, okay, or if you click and drag it here also, you can have this type of things. Okay, we can open the project here. In that we will be showing the tree will be showing the tree showing that what are the steps we are going to perform to complete the static structural analysis. Okay, so this analysis we are doing, right, this is not analytical one, we are doing a numerical one. Okay, and one more thing I have to tell it, you should not solve all the problem in numerical analysis itself. Why? Because the numerical analysis also have certain disadvantages, that is certain limitation is there. Okay, you can't able to uh, uh, analyze the uh, mechanical property of the structure, mechanical property of the material. Okay, for that you have to do the experimental analysis. Okay, so if you want to perform numerical analysis means you need a physical property that you have been calculated from experimental one. Okay, so this is this you have to know. Okay, so whenever we are performing numerical analysis, okay, there are three major steps is there. That is, first step is the pre-processing, second step is the solving, third step is the post-processing. That means pre-processing means what you have to, first we need the structure, right? So first we have to create the structures. For that we need the geometry. Okay, so you already have exposure to softwares like designing software like CATIA, Unigraphics, ProE, those things and all, SolidWorks and all. Okay, so mm, uh, 15 years back and all, we'll be having uh, that solvers and all, even that Ansys and all, not giving much importance for geometry creation. Okay, now after 2015 onwards, they are giving a lot of provisions for creating geometry itself. You can see in that if you right click on the geometry here, it gives three platforms for creating the geometry itself. So if you first thing is that space climb and design model and discover. Okay, earlier if you see the older version of the Ansys and all, you can see only the designer model, that is previously 2015 above and all, you can see only the designer model. After 2018 only you'll be having the space climb, and now after 2022 only we will be having a discovery geometry and all, they are creating that. Okay, earlier we are having separate software for a designer, and most of the analysis software they are not giving much importance for geometry creation, so they will be providing the simple geometry only. Okay, so nowadays only they are giving this kind of provisions and all. Okay, by default, if you see, one thing I have to show you that in geometry, if you right click and click on the properties, you can see this type of dialog box will be open here. Okay, by default you can see the solid bodies and surface bodies are ticked here. Okay, so you have to check this line bodies also. Why? Because now we are going to perform this one-dimensional problem means, so you have to make sure in geometry, in right click, if you go for the properties, you can see this type of dialog box over here. By default, that solid body, that is three-dimensional object, will be uh, tick, and by default the surface body will be tick. So sometimes the line bodies is unchecked, you have to make sure to check on. Okay, if you are performing one dimensional problem means you have to make sure this should be a turn on. Okay, so now if you come back to this tree, So first thing is engineer data. Engineer data means we have to give the uh, material details. Like we have a cantilever beam, right? The cantilever beam is made up of some material, right? So what type of material we are going to assign for this structure, those things and all I have to give it here in the engineer data. If you double click on the engineering data, it opens the engineering data. By default, the structural steel is selected. Okay, even if you are not selecting the structural tree, by default the structural tree is the default one. If you want to have some other materials, you can import it here also. Even from this engineering data sources, a lot of materials is available, that is structural steel also available, that is in general materials, the cast iron, titanium, all those material will be there. Okay, once if you want to use this material means, if you click on this add button, and it will go to the engineering data itself. Okay, so as of now we are good with the structural steel itself. Okay, so we can move on to the project. Okay, here first thing is I have to create a geometry. Okay, so as of now I'm going to click on new space climb geometry. Okay, so I will explain in further classes. I will explain how to create a geometry in space climb, as well as I will explain how to create a geometry in decision model itself. Okay, so this is the introduction class. So I just directly to them for demonstrate how this analysis is working. I'm just demonstrating. I'm taking one small problem. So once the Ansys baseline is open, you can see by default it will be in a sketch workbench. Okay, first the thing is we have to create a beam structure. Okay, for that I need to draw a line here. So first I think I have to click on the line here, and the space climb is very easy to uh, create a geometry. So you have to click on first starting point, and you just drag here. Okay, no need to click anywhere. You can see that in blue the dimension is changing. Okay, so if you want to fix it in certain dimension, you can see the dimension currently in mm. Okay, make sure what unit you are using. Okay, so here I want to use in the geometry. I'm going to assume it's 1 meter of the length of the beam structure. So I have to enter as 1000. You just press you just enter that value 1000 and press enter. Okay, so line having a length of 1000 mm is created. Okay, even though it is keep on the line is coming, so I need the total length is 1000 mm only. Okay, once you created that, press escape button, so you finish drawing the line. Okay, so after that, in the geometry, so here I am assuming that the length is 1 meter. Okay, for this I'm going to assume is this is 40 mm, and this length is again 40 mm, because this is a square. Okay, uh, I'm going to apply, this is 1 kilonewton is the load I'm going to apply. Okay, so for this problem I already created the line in the space clamp. Okay, after that I have to create a cross sectional area. So here in space climb itself, click on the prepare. Here you can see the profile option, right? Here only you can able to choose what kind of cross section you want to create here. Okay, so I want to create a rectangle cross sections, so I have to click on the rectangle here. Once you click on, you can see that in the tree here itself, one beam profile will be created. Okay, under if you expand this beam profile, rectangle will be here. Okay, once you click on that rectangle, you can see by default the area of the rectangle is 10 by 10, and the moment of inertia ix, iyy, the product moment of inertia is shown here. Okay, so I want to create a rectangle for 40 mm width and 40 mm height. Okay, so I want to change the value. For that, if you have to right click on the rectangle and click on edit beam profile. Once you click on this, by default will be taken the value of 10 into 10. If you want to change, that means here you can see that in ruler dimensions, click on that, and click on this default value, you can see there is a provision to change the value. For our problem I have to choose a 40, so I enter the 40, I click enter. So it's changed now. Like that I have to enter for height also. I am clicking 40, enter. So I change the dimensions. You can see now that cross section I wanted is 40 cross 40. Okay, once I'm defining the cross sectional length, I have to switch over to the original structure. So I have to click on the design here. Once you click on the design here, you can see in that structure thing, in beam profile in rectangle, you can see that cross sectional area is changes, that accordingly the moment of inertia IXS IOV also changes here. Okay, so you have to use this type of things. Even if you want to change the value, you can change it uh, using the above steps. Okay, now we created a cross section. Now we have to create a beam property. You can see that in the prepare itself, previously the create is not shown. As soon as we created the cross sectional area, now its creation option is turned on. Okay, so click on create option and just click on that edges or line you created. Okay, once you click on this line, now you can see the beam is created. You can see in the tree itself one beam will be created. Okay, you can see that for beam, for that rectangle cross section is assigned. Okay, so we need a beam length of 1000 mm, and we have the cross section of rectangle, so the beam is created now. Okay, so for geometry we created the one dimensional geometry we already created, and we assign the cross section also in the Ansys space claim itself. Okay, in next class we will be discussing more about space climb, how to create geometry. For this demonstration I just shown those things. Okay, in later classes will be explain how to create each and every things, that sketches of each and every tool in the space climb. Will try to explain all those things related. Okay, so for this problem, this is what we have to create in the geometry sessions. Once we created, you have to click on file and exit space climb. Okay, once you created, if you come back to Workbench, you can see that there we have the tick mark. That means we finished the geometry. Okay, we created the geometry part, so we have the tick mark. So the rest of the things we are not done anything, so we have that question mark symbol and we have that update symbol is there. Okay, that means it is still in process, or we are going to finish the process, or we have to some things it is not completed. Okay, that's what is meant by. Okay, once we done that thing, next thing is we have to apply the load and boundary conditions. Okay, all those things we have to apply. For that we have to double click on the model. Once you double click means it will open another workbench called as a mechanical workbench. Okay, in mechanical workbench only we'll be assigning the load and boundary condition, all those things. Okay, so we created a geometry in space climb. Okay, now here in mechanical workbench no need to import the geometry, because in the workbench itself we can see it's a tree, it is all interlinked. Okay, as soon as you double click on that, you can see the geometry is already imported directly here. No need to import separately here. Whatever the geometry you created in the space climb, it's automatically uploaded here. You can see the geometry is updated here, you can see. And for the geometry the material is assigned is structural steel. Okay, the structural steel is applied here. Okay, so here we are not assigning any additional material, right? If you want to change the material here, here itself you can change by here. If you click on the aluminum, the aluminum material is applied here. Okay, in previous version of Ansys and all, if you are not defining the material in engineering data, you can't able to apply in here. But in newer version you can able to apply the material property here itself, even though if you are not defining it engineering data over there. Okay, if you want to apply new means, like if you want to apply rubber plastic material or titanium material, or plastic material, that is a plastic ABS high impact rubber material. If you want to apply means that also you can able to apply here itself. Okay, you can directly import it from the library here itself. Okay, so here I applied aluminum. Okay, so now I'm going back to steel itself. Okay, now if you click on the cross-sectional rectangle, you can see that the area of the cross-section and moment of inertia in x direction, moment of in y direction it shows here. Okay, so since it's a rectangular one, the product moment of inertia is 0, so it's not shown here. Okay, for this static structural, what I have to do means you can see that as of now I'm not doing the mesh. Okay, so you can see only the line structure. Okay, as soon as if I click on right click on the mesh and generate mesh, okay, the generate mesh will give the default mesh for that structure, the geometry. Okay, I will explain what is mesh in itself. In numerical analysis, mesh is very important one. I will explain in later part while solving each and every problems why the mesh is very important. Okay, so as of now for this for demo, I just right click on the mesh and click on generate mesh, so the software itself give the automatic mesh. Okay, once the mesh things comes means you can see that cross section also. Okay, so now here since it's a cantilever beam, I have to assign that is one end is fixed, right? So I have to arrest the fixed support, that is I have to assign fixed support at one end. Okay, so in mechanical workbench and right click the static structural and in insert there is option called fixed support. I'm going to assign a fixed support at one end, so click on fixed support. So it asks where you're going to apply that support in which geometry, right? So here you have to select on one end. Okay, so you can see that I'm just pinpointing to the vertex, that is point. If you click on that point, you can see a green color, and if you click on apply here, you can see that one vertex is selected as a geometry. You can see the fixed support is applied about that point itself. Okay, now I'm going to apply a load in another direction. So I'm right click on the structural insert in force option. I'm going to apply a force in here at this end. I'm going to click on this point and apply here. So the one vertex is selected. You can see the red color, and here the force I'm going to apply about this point. Okay, so here you can apply the load the vector like wherever the direction it is. I'm going to apply in the component also. If I click on instead of vector, you can choose by component also, because I'm going to apply a load in y direction, that is negative. So here I'm going to give minus 1000, because 1 kilonewton I'm going to apply here. So you can see that gradually applying load is applied here by default. Okay, so this is what my analysis setup it is. So in right click on the solution and deformation total, if you click on that means, because I want to define that what was the deformations take place. Okay, so we already studied in the theoretical classes. If you want to perform if you want to calculate deflection for the cantilever beam, that is for n point load is applied, we know the formula here for the deflection. The del is equal to W L cube by 3 EI, right? So this is the formula, we know that. Okay, so we know the W value, L, and Young's modulus and the moment of inertia also. Okay, so using this formula we can able to calculate that. Okay, if I perform this analytical solution, you can see that this is the formula. You know that load is 1000 and into L cube, that is length is 1000 into cube, so that we have this value divided by 3. E is that Young's modulus we have given. Okay, 3 that is 2 into 200 gigapascal. Okay, so I applied as converted into mm, so 200 into e power 5, and moment of inertia is 2.1 and e power 5. Okay, so if you have the calculation, I'm getting the deflection is 7.9 mm. So this is the analytical procedure. We know the result. Okay, by doing the analytical one, we can get this type of result. Okay, And if we perform this the same problem in numerical, we can going to find out what was the result it is. Okay, so we already defined all the parameters here. Only thing is we have to just click on the solve button. Okay, so I'm just click on the solve button. Okay, now the analysis have done. You can see the deformation. So you can see that total deformation here we can get is 7.8221 mm. In theoretical we get 7.9 mm. Okay, so that is the difference is 0.1 mm difference is there. Okay, if you move on to this, okay, you have any queries? So till now we solved the problem, one-dimensional problems, and we have seen total deformation value, and we validate with the theoretical value. We just taken only the deformation value alone, so you can able to get stress value, as well as we can able to draw the shear force at minimum diagram and all. Okay, in later classes, in that is in next classes, we'll see that shear force at minimum diagram and all. Okay, so if you have any doubt in this session, you can ask. uh, Anyone have any doubt?
Sir, hello. Can you, sir, can you just explain how you given the processing area that part? Processing for the you even fast when you are doing that.
Okay, so if you go to the space climb, uh, so in the space climb workbench, what you have to do is like, once you created the geometry, the line, if you created that in sketch workbench, we'll
So
share
speed
it.
is shared.
Okay, sorry, I'll share the screen one at a time. Okay, now you see the right. Okay, so once you created the geometry in sketch workbenches, uh, you have to go to the prepare, click on the prepare tab, and in that you will be having the profile. Under profile you have to select whatever the cross section you want. You select that cross sections. So here we selected the rectangle one. So once you select the rectangle, you can see that beam profile will be created. If you expand this beam profile, you can see that we created rectangle will be here. And if you right click on the rectangle, if you click on the edit beam profile, there you can give the values, that is the dimensions, wherever whatever you want, you can define that dimension over here. Okay, so this is how you have to create the cross-sectional things. I hope for you it will be
Yes, sir. Thank you.
okay. Thank you. Anybody have any other doubt? So not only that, if you see one more thing I want to discuss. So here we solved on Candler beam, right? So here, in whenever you're solving the numerical problem, uh, here the tool knowledge is 20%. Maximum we need the theoretical knowledge, that is 80% is required, because we have to, whenever we consider the geometry for analyzing purposes, uh, we have to approach the problem is very important. How you approach the problem is very important, and second thing is how you apply the boundary condition is very important. and certain thumb rule is required. For example, here for this cantilever beam, if you apply the load about here, the structure will be break, right? The structure will break at where the support is placed. Okay, if you take the simply supported beam, uh, for simply supported beam, if you apply the load at that middle of the structure, okay, here the failure is take place at the middle. Okay, so in the first scenario, you applied the load at the end condition, the fracture is happened at the support region. Okay, here in simply supported in second uh, uh, in second thing, in simply supported beam, you applied the load at the middle, the fracture is happening at the load region itself. Okay, see here in the first case the structure is failed in the support region, in second case the structure is failed at the wherever you applied the loading conditions. Okay, so you can see that the two things are different. Okay, the same thing. So this is a very simplest problem. So we know for cantilever beam the structure is failed at support, and for simply supported wherever you apply the load there only uh, the failure is occur. Okay, so for simple geometry we can able to understand. If you have that complex geometry and all, sometimes based on your uh, boundary conditions the software will try to give some false stress value. Okay, that also because your based on assumption you apply some certain boundary conditions, based on that it shows some stress value in certain regions. So if you have that basic level is very thorough means, and if you have proper knowledges means, you can you can have that you can have the clear judgment about which result should be believed. Okay, because we have seen the two cases. So for one cases at supports you have larger stress value, at here wherever you applied a load that we have that stress value. Okay, so when you solve the complex geometry, there is a chance wherever you applied the load there also the maximum stress is happening, and wherever you given the support that also it shows some stress value is maximum. So you have to correlate it in a way which result should be you should believe. Okay, so for that we need theoretical as well as experience, so that we can correlate it which is correct. Okay, all because of if you apply correct boundary condition, if you apply correct boundary condition you will get a correct answers. So for that you have to approach the problem correctly. Okay, like whether you have to choose whether you have to go with 1D or 2D 3D. So that is the approach of that problem. And second thing is applying the boundary conditions in proper way. If you do that those things, and you can able to correlate the result. So these are the things we'll be learning in the uh, throughout these training sessions. Okay, so this is how you have to approach the each and every problem, not only 1D problem. We will be approaching for 2D 3 times all the problems, and we will be validated with all the results. Okay, in next classes we'll be going with the in space climb, how to create the geometry in space climb itself. We'll be fully thoroughly looking along in the space climb itself. Okay, we'll see uh, in next classes. Okay, if you have any queries you can ask me. I will clarify it out, and we can wind up this session for today. Any doubts? So Vaibhav is asking, so I already shared so it's a student version only. I shared the link, so you directly double click means if you click on next itself it can install that. Also there is a file, that is a readme file will be there. If you go through that you can able to find how to install that uh, student version of those things. Okay, so it is very simplest one. Okay, Okay, I hope you understand. Okay, thank you. Any other queries? Yes. In that uh, in that Ansys student version file itself, there is a demo video will be there. Okay, if you see the demo installation video, you can able to follow this video and you can able to install that student version. Okay, thank you. So I think none of you have any doubt in that. Okay, so I will share this video, the link to your WhatsApp group. Okay, you try the same procedure and whether you also get this result or not. Okay, we'll see that. We'll see in tomorrow classes, and we'll see in next classes we'll be totally looking on space climb workbenches. Okay, so we'll see tomorrow the same time. Thank you all.